Welcome to Biochemistry YouTube channel. Maharashtra SET exam 2020 questions with detailed explanatory answer. Paper 2 Chemical Science Part 2. Question number 16. Which of the following can be classified as labile complex? Here is chromium 3 plus, titanium 3 plus, here vanadium 3 plus. In this, lability of the complex refers to the ligands which are replaced easily in the coordination complex. If the compound is metal ligand bond are easily broken, it is referred to as labile. Whereas in the compound metal ligand bond are more difficult to break, is referred to as inert. So inert complex and the labile complex. They are given three options. Chromium 3 plus, which has 3 unpaired electron. Chromium 3 plus, it is D3, which has 3 unpaired electron, which is inert or less labile. Whereas in Ti3 plus has 1 unpaired electron. It has 1 unpaired electron, which is more labile. And the V3 plus, vanadium 3 plus has 2 unpaired electron. It has 2 unpaired electron. It is also more labile. So this is labile. This is also labile. Whereas this is inert. Hence here, in this option, B is correct. Ti3 plus and V3 plus are labile, and chromium 3 plus having D3 electron is inert. Here this chromium 3 plus, which is an inert complex. Exchange of ligand is very difficult. Question number 17. Which of the following represents the correct order of Lewis acidity? On moving down the boron family, you see the Lewis acid character decreases on moving down the group. Effective overlap between the orbital decreases due to larger size of p orbital of halides. Hence, electron deficiency of boron atom in its halides follows the trend. Here, the larger halide ion Br3 is more Lewis acid, is a greater Lewis acid than BCl3 than BF3. Because fluorine has smaller size, chlorine a larger size, and bromine is larger in size. As the size of the halide increases, the Lewis acidity also increases. Hence here, in this option, AlCl3 is more acidic Lewis acid than BCl3 than BF3. Option B is correct. Question number 18. Which of the following statement about the reaction? SbFi, fluoroantimonic acid. So SbFi HF reacts with HF to give SbF6 minus and H2F plus. This H2F plus is called as a superacid, and this is more acidic. That is this acidic character. The fluoroantimonic acid is a mixture of hydrogen fluoride and antimony pentafluoride. SbS6 minus is a simple being. The substance H2F plus is called as a superacid, which is more stronger or quadrillion times stronger than sulfuric acid. It's a superacid. Hence answer A is correct. SbFi is a Lewis base. No, this is wrong. HF is a stronger acid than H2F plus. No, H2F is a superacid which is more stronger than sulfuric acid and HF. So this option is wrong. This option is wrong. And SbF6 minus is a Lewis acid. No, it is not a Lewis acid. Question number 19. The element which causes chemical interference in atomic absorption spectroscopy is aluminium, strontium, manganese, and lanthanum. Spectral interference is also affected by the radiation of emission of line of another element or a compound, giving a radiation from the flame, solvent or sample. Here we observe a vanadium line at 3082 Armstrong and the aluminium at 3082.15 Armstrong unit. But hence here in option A, B, C and D, aluminium is given, vanadium is not given. Hence option A is correct. Question number 20. An analytical technique in which the temperature difference between the sample and the non-reactive reference material is monitored as. Here the differential thermal analysis DTA. This is a technique in which a difference in temperature, that is a delta T, is plotted of the sample is plotted against reference material is monitored against time or temperature in the specified atmosphere. Hence it is a DTA technique. In TGA technique, we measure the weight of the sample against temperature. Hence answer D is correct. Question number 21. In ion exchange chromatography, the capacity of exchange of hydrated ions Al3+, Ca2+, and Na+. 3 cations are given. In the cationic exchanger will follow the order. Listen, in cationic exchanger, M3+ is a greater exchanger ion than M2+ than M+. This is exchange capacity. Exchange capacity is more for a compound having a greater positive charge. Hence here option Al3+ is greater than Ca2+ is greater than Na+. Hence answer option B is correct. Question number 22. The percentage of bromide ion in a compound was found by 3 students. 3 data has been given: 10.2, 10.3, 10.4. The mean deviation you have to find out. Here for this 3 data, the mean is calculated. So 3 addition divided by 3 gives 10.30. And the mean deviation you have to calculate, that is 10.30 minus 10.20 is 0.1. 10.30 minus 10.30, this is 0. Here it is 10.30 minus 10.40 is minus 0.1. Here plus minus symbol was not counted here. Now the addition of these two value 0.1, 0.1 is 0.2 divided by 3. There are 3 datas, so it is 0.066. Option D is correct. Is the mean deviation. Question number 23. The reaction of NiBr2 and pH2 is ETP results in 2 products with the composition of is a complex. First product is green in color with a magnetic moment 3.2 bm, and the second product is red in color and it is a diamagnetic. The geometry of the green and red product is respectively square planar, tetrahedral, trigonal, pyramidal and octahedral, octahedral, trigonal, bipyramidal, tetrahedral and square planar. From this we can calculate. Here it is a 4 coordinated complex. It is a 4 coordinated complex. Hence for 4 coordinated complex ML4 you will get only 2 options. One is sp3 hybridization and another one is dsp2 hybridization. Hence option here, option B is wrong. Option C is wrong. Either option A or D will be correct. So we will see which one is correct. The coordination number is 4. Hence the complex is tetrahedral or square planar. Okay. in this complex, nickel Na2 plus is having a D8 configuration. In this D8 configuration, for a strong ligand, if the coordination is if it is a strong ligand, then you will get DsP2 hybridization. Here it is a DsP2 hybridization. If it is a DsP2 hybridization, there is no unpaired electron. So it's a diamagnetic complex having dipole moment 0, having mu equal to 0. Suppose if the 3D8 metal ion is having sp3 hybridization, sp3 hybridization is a sp3 hybridization. It is a tetrahedral which contains two unpaired electrons. Hence, for two unpaired electron, the magnetic moment mu is 3.2 bm. It is a paramagnetic. So, listen, if it is a tetrahedral, for a complex with a tetrahedral with the sp3 hybridization, the color of the complex is green. Magnetic moment is 3.2. For a complex which is a square planar having dsp2 configuration, it is a red color crystal which is a diamagnetic and the magnetic moment is 0. So, option here, it's the first complex is green in color is tetrahedral, the second complex red in color is a square planar. Option D is correct and option J is ruled out. Question number 24. The total orbital angular momentum L and the spin quantum number S of a term symbol G4. How to calculate? For listen here, for L value for different orbital is, for S orbital it is 0, for P orbital it is 1, D orbital it is 2, F orbital it is 3 and for G it is 4. So for G4 they are asking the multiplicity is given as 2s plus 1 is equal to 4. The 2s plus 1 is 4. So S is equal to 3 by 2. If S is equal to 3 by 2 means it has 3 unpaired electron, which shows that it has 3 unpaired electron. So here option C is correct. So L equal to 4, here L equal to 4, S is equal to 3 by 2. Question number 25. The strength of hardness of isoelectronic ion F minus, OH minus, NH2 minus and CH3 minus is in the following order. Let us take the conjugate acid. To determine the basic strength of these anions, we need to find out the acid strength of the conjugate acid. Now the conjugate acid is respectively methane, ammonia, water and HF. So now you arrange in order. HF, hydrogen fluoride is first priority and water second, ammonia third and methane fourth. Here acidity is directly proportional to electronegativity. Here fluoride is more electronegative. F is more electronegative. Hence on arranging in acidic order 1 greater than 2 greater than 3 greater than 4. Hence F minus, OH greater than OH minus, greater than NH2 minus, greater than CH3 minus. Hence here option, the given option is according to C is correct option. Now question number 26. Which of the following lanthanum ion, lanthanum 3 plus ion is colorless and colored respectively? The two ions, a pair of ions has been given. You have to identify which one is colored and which one is colorless. In this, among this ion, let us note down here, lanthanum is colorless, cerium is colorless, whereas here promethium, they are given, promethium is in pink color, whereas ytterbium is colorless and lutetium is colorless. So let us see the option. Gadolinium, they are given. Sorry, gadolinium. Gadolinium is also colorless. Here, in this option, it is green color. It is colorless. Now here, it is colorless. It is green color. Colorless. Colorless. It is also colorless. It is also colorless. Hence they are asking colorless and colored. Colorless and colored is option B is correct. Gadolinium is colorless, whereas promethium is green color. Question number 27. The total number of metal-metal bond in the stable complex of rhodium complex is. Here it is a 2 coordinated complex. Here the metal-metal bond is 2. That is the structure of complex. Now question number 28. The complex is N3 C5H5 and it's a metal N3 C5H5 N3 and 2CO. Here which metal is more stable is, here it is vanadium. Question number 29. Which statement of Fischer type carbon is incorrect? They are asking incorrect statement. It contains metal double bond carbon is a correct statement, and the Fischer carbon is a divalent organic ligand. It is an organometallic compound. In a Fischer carbon, the carbon ligand is a sigma donor and pi acceptor ligand, because pi back bonding donation, p pi d pi back bonding donation occurs from the metal center to, and the carbon is electrophilic in nature. It is electrophilic in nature. But here option given, it contains a metal in low oxidation state. It is also a correct option. It contains a heteroatom attached with metal bounded carbon. It is also a correct option. The wrong option is it is not given nucleophile. It is not a nucleophile. It is a electrophile. Hence option B is wrong, and the correct answer is B, because they are asking the incorrect statement. Question number 30. The quarter pole splitting EQ value of mass Bayer spectroscopy gives the information about which of the following? Molecular symmetry, oxidation state, spin, and S electron density. The quarter pole splitting reflects in the interaction between the nuclear energy level and the surrounding electrons, that is electron field gradient. A quarter pole splitting can be used for determining oxidation state, spin state, symmetry, and the arrangement of ligands. Hence, S electron was not related to this. Hence, option A is correct. We will meet in the next video, part 3. Thank you.